All right. Hello, everybody, and welcome to the stream. I hope everybody's doing well tonight. Getting a little bit of a late start tonight, just because I had a couple things I wanted to straighten out before stream. But that's just kind of the way it goes sometimes. So we're going to be picking up where we left off last time. Although we've moved a little bit forward, we're going to be basically doing a debugging session tonight. With that said, before we jump into that, I do want to just take a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Gabolis Inc. and Matt Osgard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over in YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover the cost associated with running this project. Things like software licenses, hosting fees, eventually probably assets, things of that nature. So thank you guys for that support. I really do appreciate it. And of course, I would be in error if I did not give a big thank you to all of you, the viewers, whether you're joining us live here on the YouTube side or the Twitch side. We do simulcast both. Or if you're just catching the VOD after the fact, thank you so much for being here. I appreciate each and every one of you guys, because without you guys, this project and this channel would not exist. So thank you guys for being here. 3D Code Warrior, good to see you. Maget's, good to see you as well. Sky, I always say Skyube. It's Scicube. My dyslexia always hits me hard with your name for some reason, but hello. Starboard Tech, first time chatter, welcome. I hope you're doing well. And over on the YouTube side, let's see. I'm going to say Kaya, because I feel like I'm going to butcher the rest of it. So hello. I hope you're doing well over there. Let's see. Is C better than C++ using Vulkan? I'll put it this way. It's a matter of perspective, right? It depends on what your code base is. I find it a little bit nicer to work with because C overall is a simpler language. And I prefer working in C versus C++. I've not used the C++ interface for Vulkan, so I can't really speak to it that much. I know when it first came out, it was a bit buggy and there were some issues with it. As far as I'm aware, those things have been resolved. But even when I do work in C++ with Vulkan, I tend to use the C API anyway, just because that's kind of also the way I write my C++. But take that as you will. I just, it's a matter of personal preference, pretty much. Okay. So what are we looking at here on the screen? So this is the output from a Valgrind, or Valgrind, however you pronounce it. Because I'm trying to troubleshoot a seg fault. Well, it's a seg fault / abort that we're getting whenever we are importing our assets using the asset importer from SMP. And so I'm basically kind of going through here trying to eliminate a few of these things. I also have found some that exist in our OBJ to KSM for our static meshes. So I'm just trying to resolve those really quickly. If I'm able to resolve those, I think everything that we've done up till now, we should at least be back to a running state. I doubt that everything for the animations are all hooked up correctly. I'm sure there's things we missed, but we're kind of at that point where we need to start debugging. So I realize, debugging is not necessarily always the most interesting thing to go through, but it is realistic, right? You spend a decent amount of time writing code, but more time actually debugging and troubleshooting. So that's what we're doing tonight. At least, until we get things up and running, we're basically just going to squash bugs with all the new stuff that we've written until we have something up and running and we're able to actually execute the application as we expect. That being said, if I go ahead and run the Shadows of Illumina project as is right now, we are able to actually run up until this point, right? So we are actually able to launch the application, and this, all of our debug text comes up, and and our debug console and all that good stuff. However, the second I load an asset, we have issues, right? And this is an assertion failure around our strings guard, and I suspect that there are other issues around this with our serializer as well. So there's some issues there we'll have to look at, and then if we actually take a look at the import all assets from manifest, and we actually try to run that here through our debugger, we are actually getting an abort. Corrupted size versus previous size. So this tells me that we're essentially writing to memory that we shouldn't be writing to somewhere. I don't know exactly where, but it is in our new logic that we're writing because it's during a export or an import rather of an assemp resource, right? And it's specifically when we go to release the scene from that. So this unfortunately doesn't tell me very much because essentially what's happening is the failure is coming from within the assemp library itself, which, we obviously we aren't set up to debug, and I don't think that that's actually the issue anyways. I think what's happening is we are writing to some memory that we shouldn't be writing to somewhere, and it's essentially clobbering some of the data that's in this structure. And then when this goes to release, it's saying, hey, I don't actually know, what's happened here. This is not the data that I expected to be here. And that's essentially what's happening here. So I've begun by using Valgrind, which is a pretty common tool to debug memory issues. It tells you about all kinds of different things. Use after freeze and things that you forgot to free upon shutdown, things of that nature. And so essentially what I'm doing here is I'm just going into the terminal here, and I'm just, and I'm executing. I'll have to scroll back up. For some reason it scrolled down on me. I'm executing this Valgrind, and then I'm using the Kohi.tools. And then we're using the import manifest and then passing the path to the manifest. So that is the same exact thing that we are running. Let me close this. In this debugger, when we go to launch JSON, so import all assets from manifest for Illumina. You'll notice here that we are running /bin, Kohi tools, and then the args that we pass to it are just import manifest. And then, of course, the asset manifest for the Illumina application. So it's just kind of two different ways to debug the same thing. And Valgrind tends to drill down a little bit more deeply than our surface level debugger, and can give us some helpful information. And so this is kind of what we're going to be looking at tonight. All right. No, this is definitely not vibe coding. Not whatsoever. Recently installed Hyperbars plugin for Hyperland, and now my windows have title bars, so you can pretty much create desktop environment out of Hyperland, which is cool. But then it's like, why use Hyperland, baguettes? Just use K3D, which is what I'm using. But yeah, I get it, I guess. But let's see, how long have you been developing? Like just software in general? I've been writing code since I've been writing code since I was 7. So that would be what, 33 years? What is the longest time took to fix any bug? That's a good question. I'll have to think about that one. It's probably been on this project, if I had to guess. Oh, goodness. I haven't really thought about that in that manner. Good question. It probably would have been something in this project, and it probably would have been something memory related, I'm guessing. Most bugs do not take me more than, a few minutes to solve. There have been bugs in the past though that have cost me a couple of days of debugging. I can't think of anything specifically, but longest time taken, I would say probably a couple of days. And that's usually something that's like super deep rooted under layers and layers of code. Generally, memory errors like this or something like that. Let's see. MDS Ubuntu with a watch streak. Appreciate that. Hello, how are you? Good to see you. Do you have a core dump? Do you have a core dump to have a snapshot of things right before it went wrong? Not yet. I'm just kind of taking a look at this, which is already giving me lots of information of things that I could solve. Invalid writes, it looks like, and I think I saw a couple of invalid reads in here as well. So I've got a few of these things with our new serializer that I've got to fix. And then I also noticed that there's also, it looks like 2 issues here with our old KSM, which is our static mesh importer from OBJs. So there's a couple of issues there. However, it looks like most of the other things are okay. It looks like we might have another one here from Ogvorbis. Let's see. Yeah, so we might have another one there, which might explain this. And then, of course, leaks, which this is just our sort of external tool chain. So there's lots of places in here where I'm not releasing memory because I just let the OS do it. So I'm not as worried about that because this particular thing that's running is just sort of a external thing that we run on the command line once and forget about it. It's not something that stays open. So I'm not as worried about that with this because it's not something that gets maintained for a long time. But all of these issues in here are certainly problems. Let's see. Might actually disable the title bars, but at least there's such an option. Like to have the window title at the top of the screen anyways. Previously, my waybar just showed the active Windows title. No title bar, Space God. Yeah, so I actually had a setup on KDE at one point where sort of it did the whole Mac OS thing where you have the sort of top bar that includes, like a clock and like a system tray and your file menu and all that stuff up here. And I used that for quite a while and it worked decently. But I don't know. These days I just kind of roll with just a simple title bar and I don't know. I don't really care that much, I guess, anymore. I care less and less about, optimizing my workstation and more about actually just getting work done these days, to be fair. Let's see. How long have you been developing C and Vulkan specifically? Okay, so C and Vulkan. Vulkan I've been toying with since it came out in 2016. Serious development with it really began with this project, which is about 4.5 years ago. C is kind of an open-ended answer because, I've always written very C-like C++ for years, and that's well over a decade. But I switched to C for this project sort of as a challenge to see if I could do it, because I'm like, well, my C++ looks like C anyways, so why not just use C? And like I said, that's been 4.5, almost 5 years that I've been doing that. And I do C in my day job as well. So, yeah, it's a bit of a convoluted answer, I guess, but that's kind of it. Is Kohi going to be a general purpose engine? At some point, yes, but to a degree. I'm not going to be developing tools like you'll see for Unreal or Unity. It's not going to be an engine like that. Like I can't compete with those guys, right? Essentially what I'm doing, the way I'm approaching this is I'm writing the features that I need for the game I'm going to develop. and just keeping things as generic as possible in the engine, and then implementing everything that's specific to the game in the game code. So it'll be general purpose from that perspective, but you might have to add stuff to it to actually make it work for a different type of game. I hope that makes sense. Pork Nachos, good to see you, buddy. How have you been? Trying to use the mouse as little as possible, so I don't even want buttons. That's fair enough. Yeah, I tend to kind of do the same thing, but still, when I'm on stream, I have to, use it to highlight stuff and whatnot. All right. Anyway, enough of that. Let's see. So we've got a couple of, and you know what? I think I'm going to tackle this from the bottom up. So we have an invalid right size of 1. And let's see. It looks like string file name, no extension for path. Invalid right size of 1. I wonder if that's a null termination issue. Okay, so it's in our importer for the models from ASIMP line 109. So that's going to be, let's see. This one, 109. Okay, so this was saying it's an invalid right size of 1. Okay, so this is trying to write to, oh, interesting. Okay, so that's got to be a bug within the function itself then. Okay, so let's take a look at that. Boy, I wrote this a long time ago. Let's see. Okay, so we get the string length, which is going to be the length minus the null terminator. We loop through the string backwards, starting at length, right? So that's going to be the last character before the null terminator. And we essentially look for the extension, which is essentially saying if we have a path that includes an extension, the extension is going to be the space before that, or the dot is going to be the last character that we use, and then also if we are, I don't think it's going to be in this because it said it was a right. So this should be, let's see, new length equals end minus start plus 1. Okay, so that makes sense. So we allocate something for the new length. And then we set the last, oh, this should be a new length minus 1. I bet it told us that in the console, didn't it? 1121. 1121. Yeah, this should be new length minus 1. And then we do a string copy of new length minus 1. So technically this new length thing should probably actually, we should probably actually just do this to account for the null terminator. Right? And change this and this to just use new length. That makes a little bit more sense, right? So that's fun. I wonder how many problems that's been causing us to date. All right, so let's do, that's actually the last thing that happened here. It looks like there was another instance of it here. Okay. And then looks like everything else is in our serializer. So let's actually quit out of this and rerun Valgrind. Gotta love one off by one errors. Yeah, exactly. Does Kohi let you define your own allocators? There's no reason you couldn't. You just would use, the way that you would do that is you would tell the allocator to allocate a block of memory from the core allocator, and it would just give you a block of memory. And then you could just dole out from that. So yeah, there's no reason you couldn't. I have a love-hate relationship with Windows. More hate though. Do like the Windows 10 Metro look, and I replicated it with Class A theme for KDE. Yeah, I can't stand any of it, to be honest. I'm so glad I switched away from it. I only use it, the only time I use Windows these days is if I have to, or if it's by accident. If I accidentally boot into it, right? Thank you for the follow. Appreciate that. Let's see. Hey, how are you? Are you also a fan of using RHIs for your engine or writing each API individually? Love the content. Appreciate that. So we aren't using a like a pre-formed RHI for anything. We wrote our own. So we have one for Vulkan, and then in the future we're also going to write a metal layer. Is probably going to be the next one that we write. So we have native macOS support there, and then Direct3D will be the last one that we write. So we are writing all of those as a sort of educational exercise in how to do such a thing, because we're writing everything as much as possible from scratch, with the exception of like format importers, like model formats and stuff, because that's not really valuable past a certain point. But everything in the runtime, we're writing from scratch, including our own RHIs. From Lake, good to see you as well. Thank you for the follow over on the Twitch side as well. Okay, let's see. Did that get rid of? Yes, that did get rid of those errors. Okay. So let me actually see. I doubt that this has fixed the entire issue, but I want to just debug this. So we're going to import all assets from the manifest and see if it poops itself. And it's still pooping itself. All right, so we must have other things here that we need to fix. So invalid write size of 1. So this is doing a memory copy. And it looks like it's our write binary that's actually wrong. So that's interesting. How many of these are actually that? Let's see. Serialize, kallocate. Wait, the kallocate is wrong? What? Serialize. Okay, that's going to be interesting. All right, so like I said, I think I'm still going to fix these from the bottom up. Incidentally, notice that our KSM errors went away, so we also clobbered those, which is good. So KSM model serializer 832. Let's take a look at that. So we want the C file 832. All right, so our write binary is essentially just a little bit of a shortcut, right, to a K copy memory call, right? So that's basically just taking our block plus the offset that we have here, and then let's see, the copy source, which is going to be here. That should probably actually be a const. Should fix that just for correctness there. And then let's see, offset is used there, and then size is used here. So, and then we essentially return the new offset, which is the offset plus size. So all of that should be fine, although the only thing I'm a little bit suspicious of is the pointer arithmetic here. So what I usually like to do is I will cast this, to a, whoops, I want to cast this to a just a single byte array, right? I'll just use U8s for example. So I cast that and then offset into that, and then take that whole thing and cast it to a void. So I don't suspect that that's the issue, but let me rebuild it and see, just to eliminate that as a possible issue, because I know sometimes that can lead to undefined behavior, doing pointer arithmetic against the void pointer. Hamlet RPG, how's it going? Good to see you. What are we cooking? So we are doing we're essentially in a debugging session. That's the goal for tonight, is to just squash bugs with all the new stuff we've written. So let's see. I don't think that actually solved the issue, but it's a little bit more correct. So this is still, yeah. So we're still getting a invalid right size. Oops. We're still getting an invalid right size of 1. So 0 bytes after block alloced. Okay, so here is where we allocated the memory, and here is where we're trying to write to it. So 718 is where we're writing to it. 832 is where, sorry, 718 is where we allocated it. 832 rather is where we are writing to it. So 832, we're writing to that here. What did I say that was? 718? Yeah, 718. Okay, so I'm thinking, let me just confirm something real quick here. 785 is what calls that right binary. Okay, so 785 is going to be like here, right here. Okay, so it's writing out the string table. Okay, so that can't be a coincidence, right? Because we saw issues with importing that as well. Okay, so we are doing a right binary into the block. The source is the string table serialized, so that's that block of memory that we get out of the string table once it's been serialized. The offset is the running offset, and then the string table size is the size for right binary. So that all seems correct. So I'm wondering, let's see, if what we have up here is actually correct. So total block size might actually be incorrect. So let's do total block size. Essentially this is just a running tally that we've kept so far up to this point after we've written everything else in the file. So we increment that by another U32 to write in the string section guard into the file. And then string table offset is going to be the total block size at that point. That makes sense. And then the string table size should be returned to us or set here. So we go ahead and serialize the binary string table here and pass out, or return out rather, the string table size. And then we say the total block size is plus equals that string table size. So that all looks correct to me on the surface. So this should be large enough should be large enough to handle the entire thing. What is, and it's only an invalid right size of 1. Pointer arithmetic and the void pointer should default to as if it were a U8, one of the few implicit conversions I actually wouldn't mind. Yeah, I agree. But I have read that it doesn't always do that. I think a lot of compilers do kind of treat it that way, but it's technically undefined behavior. So I'd rather be specific about it, or explicit. Diamond, good to see you. How's it going? Singing over on YouTube, good to see you. Is that a light reflection on your monitor in the screen recording, the whitish glow on the right part of the screen? Let's see, on the right part of the screen. I'm not sure. The whitish glow on the right part of the screen. Are you talking like, I guess it'd be here? I don't think so. I think that's just stuff I have on my shelf. Yeah, I don't see. See, I've just got a bunch of stuff on my shelf back there. So if you're talking about like all this stuff, or maybe that's like a picture frame that I have. So I'm not sure if that's what you're talking about, but. Okay. So. The address is 0 bytes after a block size of that alloc. Okay, so we allocated on 718. That's the one that we're concerned about. And then we're writing to that on 832. So invalid right size of 1. I'm wondering if that is, you know what? Let's debug it, because let's see. Okay, so let's go ahead and we'll come down here to 785. And let's see, this is going to be the serializer. So we'll do, actually I want to put a breakpoint here where we serialize the string table. And then we also want to come down here, 785 right there, and put another breakpoint there. Let's run that. Okay. So the string table size is 2449, which seems legit. If we take a look at the string table itself, back here, we have 123 strings. The data block size is 1449. And then here's the lookup table. So our lookups essentially are just a flat list of string lookups that gets encoded into that string table as well. So the total block size here is that, right, plus our 2449. So that makes sense. So we allocate the total block size, which should it take care of the whole thing. And then if we come down here, I just want to continue on to this right here. So this is saying our offset at this point. Oh, you know what I should have done? I should have taken note of what the total block size was here before we added this to it. Let me do that real quick, because that'll tell me if we've got like an alignment issue with that. So before we add to that, we've got a total block size of this, right? So I'm just gonna, oops, why did it not? Does it not allow me to copy that value? There we go. I'm just going to put that over there so that we've got that, and then continue. And then our offsets should be the same number, and it is not. Okay, so let's see, does this allow me to, yeah, copy value. Let me go over to here and just say one of these minus the other. 1430. Okay, so we're off by quite a bit. And what did we say in the string table? What did we say? 1449. Okay, I don't know that those necessarily have anything to do with one another. But I do find it interesting that we are off by close to that much. So the next thing I'm going to do is just kind of look through here and see if any of these sizes are incorrect, because they might be. Okay, so let's see, where do we actually start? So total block size, we are counting that up from the very beginning here. So we do...
Good evening, Travis. Good evening, chat. Smile.
Smudge, thank you so much for the tier 1 sub. I really appreciate that. 18 months. Holy cow. Thank you so much for that. It's been quite a while. I really appreciate that continuing support. Thank you so much for that. How have you been, by the way? Let's see. Above your webcam overlay in the actual screen recording, what looks like a glass reflection of light scattering. Oh, are you talking about like this section on the screen? It's just peeking through to the background image, if that's what you mean. That's all it is. You know what? Let me get rid of this. Okay. So I should probably also have... Oh, you know what? I don't think I have the... Let me actually do a live server on this and pull up our spec. So try not to flashbang you guys, so I'm doing this off screen. But what I want is the... Where is it? Don't we have... Oh, right. It's in submodules. Here we go. Well, I guess it's going to be a bit of a flashbang anyways, so sorry in advance. But I'm going to shrink this down. Because I just want to kind of have this here to go along with it, right? So I just kind of want to take a look and make sure that we have everything set up as it should be. So the header is all kind of one big block of data. So I'm not really too worried about that being wrong. Let's see. So the total block size, it's plus the size of header. The next thing that we have is we have a guard, which is 4 bytes. So that's here for the submeshes. Oh. I see where the miss might actually be. So we don't actually always need to have this. this should only actually happen because we do conditionally write this out, but we didn't actually conditionally add this to the block size. So we actually need to, for each of these blocks, we need to put a condition in here to say something along the lines of if header submesh count, right? Because there might be some of these sections that we actually aren't needing to write. So here's all the submesh data. And then actually filling out that data. So this only actually should occur if we actually have data there. So that's definitely an issue. Might be a big part of the issue, actually. Bones are going to be the same thing. So if header bone count, then we do all of this conditionally. And then also same thing for this. So if we have header node count, then we do that. And then animations is a little bit more funky. So we have if header animation counts, that is actually going to wrap both that and the animation channels here. But then within that, we also have the animation channels that we need to branch on potentially as well. So if, and this is going to be animations, total channel counts. If we have that, then we do the channel logic as well, which is going to be here, right? And then strings are always done. So no matter what we do, strings are always going to be written. Now, obviously, this is going to throw a wrench into all of these structures not being available. So I guess we're going to have to actually, annoyingly, hoist those up and change how they are set up. So let's go ahead and let's actually just do this. And we're just going to initialize this whole thing to 0 and then set it here. Oops, K3D submeshes, right? So we'll have to do that. And then for bones, that's going to be kind of the same type of deal. So again, we're just going to initialize that to 0. And then here, we'll just do this and then cold cast that to K3D bones. And then come down here to nodes. And we'll do actually this. I don't think this is the entire problem, FYI. I just think it's a problem. K3D nodes. There we go. And let's see. So animations is also going to be here. Again, we'll initialize that to 0. Do that. And then one more time for channels. So channels, we're actually going to have to hoist up a little bit further. Where is it? Didn't we do that somewhere? Channels. There it is. Okay, so this is just going to have to be lifted up to here. And animation channels, this is just going to be, oops, cold cast to that type. Okay. What is this bleating about now? Total submesh vertex buffer size. Okay. So this is where we actually write out those things. I'm assuming this is probably all the buffers. Yes. Okay. All right. So those things need to be hoisted up as well. So I guess animations, channels. Where is... What did we call that? So that was channel buffer size. So we want the definition of that. That just needs to be hoisted up here. So that's fine. And then total submesh vertex buffer size. So let's go to definition on these guys, take these two out of here and hoist them up here. There. All right. So build that, and then we'll go ahead and run this one more time. I'm not thinking that that's going to solve the issue, but it might help. So I'll try it here first, and then we'll do Valgrind if we need to. I think I can move past this. Actually, I'm just going to disable that for now. Oh, you know what? I shouldn't have done that. Let me do this one more time. Okay, so the total block size is still 453, 1057. Right? Okay. I guess I could just use, well, I can't, yeah, by the time I get down here, that won't matter. All right. Yeah, those are still off. So we've got something. We're not incrementing the offset enough when we actually go to write the data for some reason. So, here is, and I should probably actually put something here. You know, begin write to binary block. Just to sort of make it super obvious where this bit begins. Okay, so we do the total block size. Technically speaking, though, this should actually be within the this shouldn't actually be exceeding the size of the buffer. This should be within the buffer because, oh wait, no. No, it's not. It is blowing out the buffer because this is, the buffer size at that point was 4531. This is 4532, blah, 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 right? So yeah, we are actually writing out past the buffer, which is the entire issue. Okay. So I guess what we really need to do is kind of go through here and just take a look at everything that we're writing out. The first thing that we write out is the header, which makes sense. I don't foresee any size issues there. If we have a submesh count, then we go ahead and we write the guard for that. So that's a write binary U32. Let's check the size on that. That should just be block. It writes the U32 value at the offset, and then we're using the size of U32. That will also return the new offset. So that should be fine. Right binary array. Okay, so this, let's just make sure that we're doing this as it should be. So we have the block and then the source. That should be a constant source. I should probably fix that. The offsets, the element size, which is that, and then the number of them. Okay, so I think that is also correct. However, I do want to just make this const correct real quick, just to avoid any potential issues there. So name IDs is an array of U16s. Material name IDs is an array of U16s. Vertex counts is an array of U32s. Index counts is also U32s. Mesh types is U8s. Centers should be vector 3s, and extents should be extents 3D. So all of these are correct in terms of size. So we write these. Let's check the spec and just make sure that everything here is correct. So we write out name IDs first, then material name IDs, then vertex counts, index counts, mesh types, centers, extents. Oops. And then we have the vertex and index data buffers themselves. So this is going to do a write binary. So the source is the vertex data buffer at whatever offset. Yeah, and then the vertex buffer size. Same for the index buffer. Okay, so I think this data is fine. That's not the issue. The next thing that we do is thank you for the sub over on the YouTube side. Appreciate that. Is this a Ninja Turtles color scheme? Not quite. It's based off of the old Adwaita theme, actually. Greetings from Germany. I appreciate that. How's it going? Welcome. I was gonna say, yeah, the time difference is probably crazy. Yeah, 4 a.m. for you. Yeah, that's pretty late, but yeah, welcome. Glad to have you here. Watched a few of your videos recently. I appreciate what you're doing, man. I'm a C Rust guy myself, and this is very inspiring. Well, awesome. Thank you for the kind words. Appreciate you being here. And yeah, welcome. So what are we debugging? We are debugging the import process. Specifically, it looks like the serializer's got some issues for our new K3D format. So I actually fixed a bunch of bugs offline, just randomly kind of around the system. We've already fixed a few here on stream. And so we're just kind of debugging our way through all of these things, just trying to get everything back to working. We can actually run the application, but when we go to load up any sort of scene, it's failing. And also, our import process is not doing the thing correctly for our new stuff. So that's a bit of an issue, but we're figuring it out as we go. Oxidation is spreading. I'm not sure what you mean by that. What oxidation? Oh, you're talking about that one language. Yeah, I see what you mean. Took me a second. Okay, so the bones section, according to our spec, should have a single guard that's 4 bytes, and then name IDs, which should be a U16 array times bone count, and then offset matrices, which should be a array of matrix 4s times bone count. So that looks like that is what these two things are doing. Let me just double check the types of these arrays. But I suspect they are correct, and they are. All right. So the nodes section is next. So that is almost exactly the same. So we have a guard here. That's 4 bytes. And then we have name IDs, parent indices, and local transforms, which looks like what we have here. So these two, let's see, name IDs. Oh, we're writing those out of order, aren't we? Name IDs, parent indices, then local transforms. Those are out of order. According to ye old spec. Okay, so that's a bug. They should all be times node count, and they are. This makes me wonder if the deserialize is the same way. So I'm just going to copy these. Actually, let's actually look at that section when we are deserializing it. So it's nodes. We have name IDs, parent indices, local transforms. Is that correct? Yes. So I'm not sure why I had it backwards down below, but it looks like it is correct here. Okay. So that was an issue, although size-wise it winds up being the same thing. So I don't think it's our underlying issue. It was just a issue that we found. Okay, so animation count. So if we have animation, we have the guard for animations, which is here. And then we have the total channel count, which is a U16. So we write a binary U16. Let's just double check that function to make sure that it's doing the thing that it should. And it looks like it is. So that's good. And then let's see. We have all of these 4 arrays here are times animation count. So we have an array of U16s, an array of F32s, which is our durations. So our name IDs are durations, ticks per second. It should also be F32, and then channel counts should be U16. So let me just make sure that these types match as we expect. They should, but let's just confirm that. Okay. So I don't think it's that. And then the last thing is our channel count, right? So our total channel count is here. If we have that, then we write out a guard again. So we have a 4-byte guard there. Animation IDs, which should be an array of U16s times total channel counts, which is what we have here. Name IDs after that is also going to be the same thing. And then we have a bunch of U32 arrays, 6 of them to be exact. So we have position counts, then position offsets, position counts and offsets. All of these are U32s. So we have position counts, position offsets, rotation counts, rotation offsets, scale counts rather, and scale offsets. So that looks good. And then the only other thing is we have channel data buffer, which is it's basically an array of F32, and that is channel buffer size. So that also seems correct. So we essentially write the binary for that at the channel buffer size. So unless we've calculated the channel buffer size wrong, which we may very well could have, we may need to rethink that. We should probably also take a look at all of these frees here, because we might have bungled some of these things. So let's see. We write the string guard, and then we do the write binary for the string table. All of that looks to be legit. We always want to write the string section regardless if there's anything or not, which are pretty much always will be. And then we clean up the submeshes. So the submeshes, again, should be name IDs, material name IDs, vertex counts, index counts, mesh types, centers, extents. I don't see any issues here. In terms of these frees, these should be fine. Bones, again, is just name IDs and offset matrices, so those are fine. Nodes is name IDs, parent indices. Those are both U16s, and then local transforms is map4. Name IDs U16, durations F32. Yeah, this all looks good. And I think these are all good too. And then channel buffer size. Okay. So, not seeing anything that immediately sticks out to me here. Unless we calculated, maybe the channel buffer size wrong or something. So I guess let's go ahead and take a look at that. So the channel buffer data, essentially, as a reminder, it's a buffer of F32s that stores all position, rotation, scale data for all animation channels. The overall size of this is determined by how many keys each channel has, as well as how many channels there are. Bytes extracted from this vary by the type of data being extracted. So a key vector 3 extracts 4 F32s, whereas a key quat extracts 5. Because that's the timestamp and then the actual data. So I am wondering if we actually just kind of bungled that a little bit. Okay. So I think all of these arrays are fine. Here we go through all of our animations. We keep a running tally of all the channels, the channel counts, durations, all that stuff. I think this is probably fine. This is where I'm thinking we might have gone wrong somewhere. Specifically, when we're talking about the, let's see, channel buffer offset. Did we actually... Where do we actually get the... Oh, wait a minute. Wait a minute. That might actually be... It's referenced a few times. So we write that there. Channel buffer size. Channel buffer size. Okay, so here we go. Okay, so here is where we increment the channel buffer size. That is where it is initialized. Okay, so it's initialized to 0 as expected. So for each animation, yeah, it should be fine. So each animation, we loop through the channels of each animation, and for each of the channels, we basically push that data into that array. So all we do here is we basically say we need a size of for the type of data that we're pushing in, and then the number of things, the number of elements for that type of key that we're pushing in. So position and scale are both represented by vector 3s, and the rotation is represented by a quaternion. So I actually don't see any issues here either. We do keep a running tally of all that stuff, so I'm not really seeing an operator precedence should handle the multiplication before doing the addition. I suppose we could be a little bit more explicit about that, but I really don't think this is the issue. In fact, I'm pretty sure it's not the issue. But let's do it anyway. Let's be pedantic about it. Let's just do that. Is the calculation in right binary array correct? I'm pretty sure it is. Right binary, right here. So what we do is we just do right binary block source offsets. Let me make sure that those are in the right order. Yeah, block source offset. And then for the size, we do the element size times the count. So write binary array. Literally just takes in, like, I think we've even validated that all these types are correct. So I don't think that's the issue. You should write the minimum amount of inline CSS to get dark mode on that page. Yeah, maybe. maybe. Let's see. Hello, what are you planning? First time chatter, welcome, by the way. So we are in the debugging mode for this stream, at least. So right now we're debugging our serialization and ultimately deserialization routines to get to the bottom of some issues that we're having with those things. So, we've written a lot of code in the last several streams, and now it's time to actually execute it and get to the bottom of any bugs that surface. And that's kind of what we're in the middle of at the moment. Let's see. Beautiful code. Thank you so much. I appreciate that. Be nice if it worked correctly, though. I mean, most of it does. We just have bugs to fix, right? But yeah, thank you guys. Appreciate that. Okay. My cats. Yes. Okay. All right. I'll go ahead and do it. We'll do this one here. Right, and then I'll just do, I think I can use that. Better. I don't like to use pure white text because I find it a little bit too jarring, actually, but yeah. At least it's not a flashbang anymore, right? Oh, that one's still wrong. Let's see. Do I have a... Yeah, that's this one. Let's just do that. Oh, now I got to do the links. See, this is why I wasn't going to do it. Like, now I have to do the links, which is annoying. So let's just do a visited, a active, and I think a focus. Yeah. And I'm just going to do color FF6600. Nice orange color. There. I'm done styling this page. It's as much CSS as I ever want to write in stream. Okay, so ship it. Yeah, right. Okay. So I feel like I'm probably going to need to take some snapshots along the way. And maybe what I could do is actually like write out some of this stuff to the console. As we're sort of calculating it, right? So whenever we go to, I guess whenever we go to write the guard position, right, we could actually just kind of spit that out. So let's go ahead and say right before this, we'll go ahead and do just a K debug. And I'm going to go ahead and say, let's do submesh guard offset equals. And then we'll just do that. And then we'll say total block size. And then I guess we can just take this and do a search for guard and just put here. right? So this is going to be the bone guard offset, and then the node guard offset. Right, and then this will be animation guard offset, and finally the animation channels guard offset, right? And then we're going to take this and, oh, I guess we should probably do the strings one too. Strings guard offset, right? So we're going to take that, and then we're also going to write this out for here as well. So we're going to do submeshes guard offset, and I guess we can put something, right, just to kind of indicate that it's like the actual right. So we'll take this. Oh, and this needs to be offset instead of total block size. So we can actually kind of just quickly get a handle on where the offset has gone wrong. Right, so this is the bones offset nodes animations and finally animation channels guard offset, right? Oh, not finally, actually. There's also the string guard, right? So we can go ahead and write that out and then rerun this guy. All right. Now we can kind of just take a look at the debug console and see, you know, kind of where we wound up, right? So like submesh guard offset 132, that matches down here. Bone guard offset 450 6785, 450 6785. So that one's good. Nodes is 451 0221. That matches as well. Animation guard is 451 4781, 451 4781. So that matches. Animation channels guard is 451 4799. Here we go again, 451 4799. And then here is where the actual mismatch is. Interesting. So strings guard, right? And then string guard offset down here is mismatched. Now I could have done this, you know, I could have put some logic in here to like catch this as we're writing it out, right? But like once we figure this out, we're not going to have to validate all of this stuff. So I didn't really see the purpose in doing that. Like once we figure this out, we'll have it figured out. So what this tells me is that the strings, when we were doing our initial calculation on how big the block of memory needed to be, this is where it thought that the strings table should be in the file. But really, as we iterated through it, it actually wound up here, which is later in that block of memory, which means it blows out the end of the buffer. So that is indeed where the problem is. So we just have to figure out why. So we know this one is correct. It's just this one here that seems wrong, which is interesting. So, and it's actually not where that starts, it's where it ends. That's the problem. So actually I'm wondering, did we have a total channel count up here? So we do total block size here. We loop through the total channel count here. Total channel count is kept by so we start off at 0, we loop through all of our animations, and then we capture the channel count for that particular animation. So that seems right. Okay, so our total channel count should be correct. All of these arrays are based off of that animation's total channel count. So that should also be correct. I guess what we could do, I'm wondering if it's like the channel buffer size that's just wrong. Arguably the most important work of the day is done. No more eye strain, right? Fair enough. It's like watching a movie. It's very exciting. Cinematography is a bit boring. That's fair enough. Fair enough. If it was riveting, everybody would be doing it, right? Oh. I see the bug. Classic dingus-oriented programming here. This should be animations total channel count all the way down. Now I bet it lines up. Dingus-oriented programming. You know what? That actually deserves that. All right. So let's rerun this again. It's still pooping itself, but are we closer to the cinema, right? There's some cinema for you. Okay, so these are still correct. Strings guard offsets. 453, 2, 3, 7, 9, 453, 2. Oh, we're much closer anyways. But we're still off by what? A couple, not even a couple hundred bytes. Okay. Why would we possibly be off again? Do we have... So total channel count. Let's do a search for animation count real quick. And just see. Okay, so here we are iterating the channels or the animations again, grabbing the animation. Okay, that's actually correct. And then let's see. Channel, so we get the channel. And then we save off the counts. That looks correct. And then we're doing the position size of the channel that we're loading in is going to be a vector 3 key times position counts. This is going to be, the rotation size is going to be the quaternion times rotation count. And then scale is going to be again a vector 3 key times scale count. Okay, that makes sense. And then we have to do a, wait a minute, did we? No, I think this is correct. Okay. So we do a copy into the channel's data buffer. which we should have already gathered how large that is by channel buffer size. So channel buffer size, where do we actually do? There's the allocation right there. Okay. Oh, wait a minute. Here are the missing bytes right here. Right here. We're missing one of these. That's probably actually enough to make up the difference. Because there's animation IDs, then name IDs. Both of those are U16s. We are missing one. So there's another one. All right. So let's relaunch this and see. Oh, it looks like it did it. Problem solved? Question mark. Yep. Yep. They match. Perfect. All right. Problem solved. Bug fixed. Awesome. Okay. I figured when I was writing this, we were probably going to get some of those wrong. I think what we need to do is we probably need to clean some of this up and make some functions to sort of guard us a little bit from that. But I think for now we're okay. At least this works as we expect now. Let me go ahead and just one more time run this through Valgrind just to see if it picks up on anything else that it says, hey, you're being a bananas there, guy. Cut this out. Obviously, it does run quite a bit slower, but I'm interested to see if it actually spits out anything relevant to this. I'm thinking we've got it right. At least for this half of it. All right, we've got a couple things up there going on. Oh, that's right. We do have an issue in here I need to eventually fix, but let's let it roll through everything else, and we'll check out to see what it is bleating about. This is still saying that we might actually have some problems with that around the same thing. So we might actually still have animations and animation channels look like they might still be not correct during the preparation phase, actually. Okay, that's interesting. And then looks like we've got a couple of other read issues up here. So let's actually look at this one since it's pretty easy to tell where that is in the logs. So this is within the animation guard offsets. So this is going to be serializer 656. So really here? That doesn't make any sense. One of the few places we use C++, by the way, for those of you who are interested in that kind of thing. Is this Valgrind? Yes, it is. Yep. Okay, so I'm wondering if it means this actual line. Okay, set model animation. Invalid read where? All these types match as far as I can tell. Okay, set model channel. Literally don't see anything wrong with this. Step it through, step it through. Yeah, I mean, I don't think stepping through is going to actually tell me anything, though. Because the thing is, it actually runs correctly. right? This is actually complaining about a read that's done here against an allocation that was done, let's see, 635. So 635 would be what? Up here. So channel counts. Should be a U16. Right? So we create this channel accounts here. Oh. Wait, no, that's correct. Yeah, that's correct. Okay. So it's 656. Oh. Wow. Wait. What was I actually trying to do here? This should be channel counts I. That was completely wrong. Golf clap on that one. All right, let's run this again. I must have been like reading chat as I was typing that line or something. Noticed it faster than I managed to write it. Yeah. I was like, wait a minute. Something is not right on that line. Okay. Looks like we still got some things, but I'll bet it's a shorter list anyway. Just gonna let this finish running. Genuine question, why did you choose to use CPP for a few lines? I mean, it's not CPP, it's me joking because I called the iterator C. Right? So the iterator here for my for loop is called C, and then I was iterating it here, so I literally typed out C++ in the code. So I was just saying this is the only place I'm using C++, but it's not C++ the language, it was just a joke. Yeah. Anyway. Okay. Yep, it fixed it. Yeah, because the one that was in here is gone. So the animation channels guard offsets. I probably did something stupid in here too. So here's the guard offsets. I'll bet I did this. Yeah, you know what? This is a copy pasta. So this should be C is less than channel counts sub I. All right, so I'm going to run this again. So might as well work out all these bugs while I find them, right? And it instantly caused you problems. You know, that's actually super funny, McGats. The one time I used C++ in my code and it caused me problems. It's very funny. You know, it's like every time I think about, you know, C++, it really should just be like...
I said forget about it, cuz.
Just that. All right. Okay, that fixed that one. All right, so we just got a couple left here. Might as well knock them out, right? Okay, so we have a reallocate here during our import. So invalid read size of 2. We got an invalid read size of 2 on a realloc? So a realloc of a realloc. So that must be something that we're... Oh, I wonder if this is... Let's take a look at that real quick. So let's... 470 in the model importer. Uh, 470. So that would be this one, which we are reallocating. But why am I getting an invalid read on that? Oh. Let me take a look real quick at K reallocate, because I think, no, that does take U64s for the old size and the new size. Okay, so that actually shouldn't be a problem. Okay, so essentially what we're doing here is we're calling reallocate on the children array here, pushing an additional entry essentially. So we take the size of a U16 times the current child count, and we're essentially expanding that times child count plus 1. Oh. That should be... Ooh. How do I make that... I see what the problem is. I guess for... count, I guess we do it this way, because we want the addition to happen before the multiplication. And if we do that, then this should expand correctly to do the addition and then multiply by that. I think that's the problem, actually. Okay. All right, let's run this again. It'd be nice if we get all of our importing issues done, because then we can actually focus on actually getting the thing loaded and like maybe drawing. Well, I don't think drawing is going to happen tonight, but soon. We're at least getting our pipeline sorted. Hey, look at that. No errors. All right, I see there's some issues with importing audio files. I might just put a pin in that for now. Okay, cool. So that is pretty much good to go on there. So I should be able to go through now. And I'm actually just going to turn off all my breakpoints. And I want to do, I want to retest all of these, because we basically have to re-import all of our assets because we changed that magic number, the asset magic number. So I'm just going to run this. Should work fine. So there's the Illumina one. Let's run the one for testbed. This one was seg faulting before, but now it looks like it might be good. Okay. So let's do for the runtime library. This one should be quick. Okay. And let's do for the standard UI. This one should be even quicker. Okay, cool. No more seg faults as far as that goes. So now when we launch Illumina, what happens when we try to load? It's probably not going to work, but okay, so we do still have an assertion failure on loading the guard for strings. I am going to guess we probably have some sort of similar issue with our deserializer that we had in our serializer. So let's do deserialize. And let's take a look at how all of that is lined up with, the sort of spec over here. So again, we've got the header. So I'm not really too worried about that. I do need to actually probably clean this up and have like a read binary instead of having to do this all over the place, but it's already kind of written, so I'm going to leave it for now and just probably go back and clean it up later. Let's see. So how do we want to... The first thing we have to do is when we go through the submesh count, okay, so we're calculating the total vertex and index buffer sizes here, which we're doing by going through all of the submeshes that are in there, looking at the mesh type of each one, then saying, okay, based off of that, we use the size of the correct structure, either vertex 3D or skinned vertex 3D, times the vertex count for that particular submesh. So we have to do that to get the total vertex buffer size, and then the total index buffer size is always using U32, so that's fine. Index counts there, that looks fine. And then the vertex buffer, of course, we just pull directly out of the file, just using the offset on there. So that's fine. Let's see. Okay, so submesh counts. Wait, did we read? Yeah, we read. Wait. Right. Okay, so we read the header, and then we read the very next guard, which will be the guard of the section, the next section that is available, right? So if we had submeshes, it'll be the submeshes guard. If we don't have submeshes, then we have bones, then it'll be this one. If we don't have any of these things and we only have strings, then it'll come all the way down here and be the strings guard, right? So this is basically to tell us, are we reading the correct section guard and its correct value for where we are in this based off of what was included in the header. Which actually seemed to work because we didn't get an error until the strings table, right? So I'm actually going to skip. Let's see, bones and nodes, although nodes I do want to check to make sure that the order of those is right because we did have an issue with the serializer. Name IDs, parent indices, local transforms. Okay, that looks fine. So animation count. This one was one that I think we probably need to, like animations in general, we probably need to make sure that this is correct. So we have name IDs, durations, ticks per seconds, and channel counts. That is all here. And the types look like they are... Wait a minute. Nope. Okay, that's correct. Yeah, that's fine. All right. So that looks fine. Read the next guard. The next guard, if we have animation channels, should be this. I think that that's true. Let's see. Do we... Okay. So let's see. We get all of the animation data. So the animation data is just... Wait. Yeah, that's fine. Okay. Animation channel data. Let's see. We have animation IDs, which is an array of U16s, times total channel count. Yes. Okay, that should be times the channel count. Okay. All of these should be total channel counts. Looks like it is. Okay. So animation IDs and name IDs, those are both U16s. And then the next 6 things are U32. So counts and offsets for position, rotation, counts and offsets, and then scale counts and offsets. Okay. And then the actual data buffer itself, which we get that size by doing... Oh, this is wrong. There's the bug. This should not be... This should be the... what is it? Animation key vec3. What was it called? That is it, isn't it? Why is that not... What? Oh. K-asset model key. That's what it was. Typed the wrong type in here. So this should be that, and then that, and then model key quad. Oops, model. Okay, so that's definitely part of the problem. Okay. We did get that right on the output, but apparently not reading it in. That probably will account for the difference in the buffer size, actually. That probably, if I had to guess, is probably the entire issue. However, where that stuff actually gets read in, I do just need to make sure. Yeah, it looks like we're doing the correct thing here. One more thing. I believe it was supposed to be position, rotation, then scale. I should probably note that in the spec, actually. Let's see. All right. What did the... I'm pretty sure that we did... Positions, then rotations, then scales. Okay. So in our spec, down here, animation channels, buffer. Okay. Stored as, or each channel is stored in the order of position, rotation, then scale. Okay, just so that's explicit. All right, so let's build this and run again. Okay, so at least we got this far. Let's load. Okay, So we got a seg fault. Let's see. Any idea as to why in here? Do we have any errors? Does not look like it. Okay. So model deserialize failed. Okay. So it looks like there's still some deserialization issues. So we want to copy from submesh vertices. Well, there you go. Submesh vertices is not allocated. Whoopsie. Okay, so that is going to be in our serializer. And that's going to be, what, 327? Oops. We need to do a submesh vertices equals k allocates. Submesh vertex buffer size, and then memory tag. What do I want to use for this? I guess I could do binary data, I guess. Also need to do the same thing for indices. So submesh indices equals k allocates submesh index buffer size. And then we'll just say binary data here as well. Oops. I guess I could say array. I guess it doesn't really matter. It'll matter more when I go to free it, I guess. There's probably going to be a few of those in here too, I'd imagine. Yeah, okay. I'm not surprised. Let's see. Oh, our binary string table is throwing an issue. Okay, that's cool. So we'll have to debug that. However, I am out of time tonight, so let me just catch up on a couple of chats, and then we're going to have to end the stream. I'm going to find somebody to raid. Let's see. Why not OpenGL? OpenGL is deprecated, right? So, I mean, I could use that, right? But like the whole point was to do this using Vulkan. So we want to use this. We want to do this using modern graphics API. So Vulkan's the first one. We're going to be supporting Metal for Mac OS, and then we're going to be supporting Direct3D 12 as well as Vulkan on Windows at some point. Just as sort of an educational exercise on how to implement all of those different things and make them cohesively work with a engine that knows nothing about any of them. It's kind of the point there. The only reason I might ever do OpenGL is maybe for like legacy device support, where Vulkan support isn't really very good, or maybe for mobile. I haven't really decided yet. But that's a big maybe and is like low on the totem pole in terms of priority. Navy Me, how's it going? You have really good and really bad timing because you caught me while I'm streaming, but I'm about to end the stream. So, welcome. All right. Speaking of which, let me find somebody to raid. And I'm hoping that I can maybe find somebody that's doing something kind of related to what we're doing. But we shall see. I see a couple of things, a couple of options already. Let's see. Just trying to find somebody that's doing something kind of related. Let's see. So while I'm doing this, by the way, if you haven't already followed me, either on the Twitch side or the YouTube side, I would greatly appreciate a follow. I am trying to grow the channel still, so if you would follow me on one or the other, if you're not already, I would greatly appreciate it. You know, all of those follows and likes and all that stuff mean the world to me, so I definitely appreciate each and every one of them. Okay, I think for tonight... You know what? Actually... This is kind of interesting. Let's go look and see what this person is doing. I've not rated them before. Looks like they're writing a physics engine. So we're going to go check that out, actually. That might be interesting. I'm not going to be able to stick around because I'm going to have to raid and run. But we'll go see what they're up to. It looks like they're writing it in C++, which is interesting. So we'll see. We'll see about that. But yeah, thank you guys so much for being here. I appreciate you guys. And we will see you on the next stream tomorrow night. See ya.